Today, we're sharing an episode that we originally released in 2020 about Parkinson's disease and a $30 million phase 3 clinical trial that investigates whether exercise can slow Parkinson's disease progression. The trial is led by Daniel Corcos, a professor of physical therapy and human movement sciences here at Feinberg. He discusses background on Parkinson's disease and how exercise may impact disease progression. The trial started in 2020, now has more than 100 participants across 29 sites. Erin Spain is host of the show, and she will take it from here. Let's jump right in.
But before we get started, please subscribe and ring the bell to be notified of new videos.
Thank you, Erin, for inviting me. I'm very honored.
I would like for you to share with us some background on Parkinson's disease. How common is the disease today? What are the symptoms and what are the current treatments?
Well, about 60,000 Americans are diagnosed every year with Parkinson's disease. There are over 1 million people in America who have Parkinson's disease. And by 2030, it's expected that more than 9 million people in the world will have Parkinson's disease. So it's a disease which is partly related to aging, and as the population ages, we will have more people with Parkinson's disease. The classic signs of Parkinson's disease are tremor. So you have a limb which is at rest and it beats at about 5 to 6 beats per minute. If you move the limb of a person with Parkinson's disease, it resists movement, and so the person is therefore rigid. And also people with Parkinson's disease slow down. So the movements become slower. As the disease progresses, people also have postural instability. So the disease is diagnosed based primarily on 2 of the 3 cardinal signs, the rigidity, the tremor, and the bradykinesia. There are also many other symptoms of Parkinson's disease. It's becoming very, very clear that people with Parkinson's disease over time can suffer from mild cognitive impairment. There's also depression, there's anxiety. There are a whole lot of other non-motor symptoms which are very, very important to treat, as well as the primary motor symptoms of the disease. The treatments to Parkinson's disease can be broken down into 3 major treatments. The first and the most long-standing is medication. The main drug prescribed is Sinemet or levodopa, and that's been around since about 1967, and it's the mainstay treatment for Parkinson's disease. There comes a point in time when the medication starts to work less well, and some of the symptoms become quite bad. And so the second major treatment for Parkinson's disease, for people who've had the disease for a while, for whom the medication isn't working well, who start to have extra unwanted movements, so-called dyskinesias, the treatment is deep brain stimulation. There are 2 different target nuclei in the basal ganglia for deep brain stimulation. The most frequently used target is the subthalamic nucleus. And so there is deep brain stimulation for the subthalamic nucleus. For a subset of people, the globus pallidus is possibly the preferred target. And then the third line of treatment, which has become more and more popular over the last perhaps 10 to 15 years, is exercise of different modalities. There's very, very powerful converging evidence from epidemiological studies whereby people have looked at people who exercise throughout their life, and there seems to be a slightly lower incidence of Parkinson's disease. There is compelling evidence from the laboratory that if you make primates or rats or mice Parkinsonian by administering some form of a toxin, that exercise is very, very beneficial and helps the animals considerably. And then there's been a series of studies which have shown that various forms of exercise modify the symptoms of Parkinson's disease. I want to be very clear what I mean by modifying the symptoms of Parkinson's disease. The idea is, for example, if you take medication, your tremor may be less, your movements may speed up, and that modifies the symptom. And when you stop taking the medication, then it returns.
Mm-hmm.
It's not doing anything for the underlying disease. Several forms of exercise have been shown to help people move faster and to get a little bit stronger.
And you've been studying Parkinson's disease. Tell me a little bit about your background and then how you began to study exercise yourself as a treatment for Parkinson's.
My background is in the study of human movement, and my career started out by looking at how people control arm movements, upper limb movements. I was very privileged. In 1994 to 1995, I did a sabbatical in England, and I had the pleasure of working with Professor John Rothwell and Professor Marsden, and I spent a year studying Parkinson's disease. And at the end of the year, we published a paper showing that people with Parkinson's disease, when you take them off their medication, become weak. So the first inkling that exercise or some therapy might be helpful came from that finding, because clearly if the disease is making the person weaker, that's not helpful. And therefore one can ask the question, can one provide therapies or treatments which can compensate for the weakness?
And you conducted a successful phase 2 clinical trial recently about exercise as a treatment. Tell me about that and how it's led to now this phase 3 trial.
I will give you a fairly long story behind this. So that once we'd shown people were weak, I decided to run an intervention to see whether strengthening people with Parkinson's disease can help them. And in fact, we ran a 2-year intervention study. And in 2013, we published a paper in Movement Disorders showing that progressive resistance exercise reduces the symptoms of Parkinson's disease substantially. And this was the clearest evidence to the time that resistance exercise is very beneficial for people with Parkinson's disease. As an aside to that, it also turned out that we showed resistance exercise improves cognition. So in 2015, we published a paper in Movement Disorders showing progressive resistance exercise improves cognition. In parallel with my resistance exercise studies, it is well known, and CDC guidelines are quite clear, that resistance exercise is good for you and endurance exercise is good for you. And so in 2009, we decided to design an endurance exercise study. And this was the SPARK study, and we published the results in 2018. This was a phase 2 clinical trial. And in the phase 2 clinical trial, we showed 3 important findings. We showed that people can work out on a treadmill 3 to 4 times a week over a 6-month period, and that they adhere to this. We also showed that they can work out at either 65% of their maximal heart rate or 80 to 85% of their maximal heart rate. And we needed to demonstrate these 2 facts before going on to a larger study, because if people won't exercise for the number of days and they can't reach a target heart rate, then there's no point designing a bigger study. And then the third thing we showed was that there are potential and possible benefits for working out at 80 to 85% heart rate in terms of disease progression. But it wasn't what the study was designed to show. It just showed that this is possible and it's promising. So once we'd shown that it was feasible to work out 3 to 4 times a week, that people would adhere to the heart rates, and that there was some potential promise in terms of slowing the rate of disease progression, we wrote a phase 3 clinical trial. And last year, we learned that our phase 3 clinical trial was to be supported by NIH.
And this trial, you mentioned Sparks. So this phase 3 is called Sparks 3, and it's funded by the National Institute of Neurological Disorders and Stroke. And this $30 million investment is currently their largest investment in Parkinson's disease research. So describe to me what this trial is going to be. How many participants will there be? Where are the recruitment sites? And what will you be asking them to do? You're obviously, looking at exercise and trying to see about this high intensity aerobic exercise. Tell me about the trial.
So we have 29 sites, and they are scattered over the USA, and there are also 2 sites in Canada. So we have 27 sites in the USA, and we have 2 sites in Canada. At these 29 sites, we will be recruiting 370 people who have recently been diagnosed with Parkinson's disease and who have not yet started to take medication. It's very important for this study that people have not yet started to take medication, because the effects of medication can potentially confound the results. So what we're really interested in is how exercise affects Parkinson's disease. We're building on our phase 2 clinical trial in that people will exercise 4 times a week. They will have a 5-minute warm-up. They'll exercise for 30 minutes. They'll have a 5-minute cool down. They'll exercise 4 times a week. And the study is going to be conducted over 2 years. Over the first 18 months, people will be tightly supervised and supported by the study teams. So we'll have an 18-month intervention, and then we will follow people for 6 months, because we want to see how well people can continue to exercise when we remove the support. Because it's well known that it is hard for people sometimes to keep on adhering to an exercise protocol.
Yes, whether they have Parkinson's or not, it can be difficult for folks to continue.
That is true. So people will be randomly assigned to one of 2 conditions. It's very important to stress here that both exercise conditions are very, very good for somebody. So if a person is randomized to either condition, this will be beneficial to them. In one condition, they will exercise at 60 to 65% of their maximal heart rate. And the easiest way to understand what this means to you is if you go out for a pretty vigorous walk and you can still have a good conversation like Erin and I are having now, that means you're about 60 to 65%. 80 to 85% is different. That is definitely working out hard. It means that your heart is beating at 80 to 85% of the maximum that it can do for a 30-minute period. And the question we want to answer is whether there is a benefit to exercising at the higher intensity in terms of slowing down the rate at which the disease progresses. No drug has been shown to slow down the rate at which the disease progresses. Everybody is looking for treatments to slow down the rate of progression. And we hope that at the end of the day, that there is a difference between the groups, but it's very important to stress that the 60 to 65% is well within CDC guidelines, and there's no question it will have a benefit for people doing that.
I did have a follow-up question there. What is the typical progression of Parkinson's disease from the onset of symptoms?
The typical progression, so a person will start with perhaps some tremor. One other potential giveaway is if people look at their writing, they may have micrographia, which simply means that the handwriting becomes smaller and smaller. One's step length may become a little bit shorter. Then when people walk, most healthy people have a vigorous arm swing. People with Parkinson's disease have a reduced arm swing, and it starts to become a little bit asymmetrical. And so as the disease progresses, then the tremor gets worse, people become slower, you get greater rigidity, then you may or may not, it varies from person to person, you may get mild cognitive impairment. What starts to happen after a while is that the medication becomes less effective, and then as the disease progresses further, It is possible for people to have dyskinesias. This is when the limbs start to move in an involuntary way and one starts to lose control over that. It looks very different from tremor, but it's also an involuntary movement, and it's partly related to the medication. That's the point at which people often are recommended to have deep brain stimulation. Also, the posture becomes a little bit worse. You have a flexed posture. So the classic Parkinsonian figures, if you ever see them in books or textbooks, is you have a person with a fairly severe stooped posture. Then there are many other side effects as well. So it is a motor disease, and so it really affects everything which is motor. So people start to talk more slowly, and their speech becomes harder to hear. And there are several other side effects of the disease as the disease progresses.
There are some cases of younger people being diagnosed with Parkinson's disease, but the average age and the age for this particular clinical trial is between 40 and 80 years old. Is that right?
The inclusion-exclusion criteria for this study are 40 and 80 years old. Some people can get the disease very, very young, and it's called juvenile onset Parkinson's disease, and that's a different disease. But some people can get idiopathic Parkinson's disease as young as 40. We cut off the age at 80 because we didn't want the results to possibly be confounded by having people in there above the age of 80, because then aging becomes a bigger factor. But I should make it very, very clear, this program is very good for people above the age of 80. It's just in clinical trials, you tend to have inclusion and exclusion criteria to make the population relatively homogeneous. But I would certainly encourage anybody listening who's in their 80s, exercise is great for you, and I would do it.
And diversity is important to you for recruitment of this study. Who do you hope to see represented in this trial?
Diversity to me is very important. I think that everybody in America should, if at all possible, have access to all treatment interventions. I think at the moment, it's fairly clear that if people are not in great health, it makes them vulnerable to other diseases as well. And so we have built in a very, very vigorous outreach program. It's well known in many studies that the population tends not to be diverse. This has been studied extensively by NIH. We have a rigorous outreach to the Hispanic community, Chinese community, Black community. And if we can, we would like to have the enrollment certainly match the population of America. This is a very, very tall order. One thing we have done is we have recruited Morehouse School of Medicine. It's a historically Black college in Atlanta. They have a wonderful young neurologist who is very energetic and very dynamic. And we have a recruitment committee which focuses on diversity. It's chaired by a neurologist at Northwestern by the name of Dr. Danielle Larson. And she is very passionate about making sure that the wonderful treatments that are offered by Northwestern extend to the population at large. And so this is a major initiative for us, and we hope, I was going to say plan, we either hope or plan to achieve this goal.
You're also going to have participants go through genetic testing. Why is that important?
The genetic testing is important because it is possible that people with Parkinson's disease respond differently to exercise. In the SPARKS-2 study, we noticed that some of the people responded very, very well, and other people didn't respond quite as well. And so this gives you a lot of variability in your response. Now, the SPARKS-3 study is designed to test what is called the superiority hypothesis. That is, that one of two treatments is superior to the other. And we certainly have a hypothesis of which of our two treatments may be superior. But a lot of clinical trials do not succeed. There is a long history of phase 3 clinical trials not succeeding. And one possibility is that there is a lot of variability in the responses of people. And one source of this variability could be their genetic profile. So there are several different genes associated with Parkinson's disease. And it's certainly known that in some treatments, like deep brain stimulation, if one has what is called a GBA mutation, one may not do quite as well with brain stimulation as if one doesn't have the GBA mutation. So what we will be doing is we will have the genetic panel for most, if not all, of our 370 participants. And then we'll just be doing exploratory analyses at the end of the study to see if we can learn whether any of the different genetic subtypes respond differently to exercise. It may be the case that some respond more and some respond less. And this is consistent with personal medicine, whereby physicians are trying to tailor the treatment to the particular genetic makeup of an individual. And it's very clear that for those people who treat people with Parkinson's disease, that the trajectory of the disease is not the same for each and every person. The way the disease manifests is not the same. And the more we can understand about the basic underlying biology of the disease, the more we can target treatments. It is, in fact, theoretically and practically possible that what works for one person well may not work for another person. And it could turn out that high intensity is better for some people and low intensity, it turns out, is better for others. And we will have the data at the end of the study to be able to look at all 370 people and determine which of those responded well, which of those didn't respond well. And we're also going to have blood biomarkers. And so we can look at neurotrophic factors and inflammatory factors. And so we'll have the gene, neurotrophic, inflammatory factors, and then we can kind of tease apart and build an understanding of whether one exercise prescription for all works. And certainly that's the idea behind the superiority hypothesis, that you can then say without a doubt, this is the best treatment. Or whether it turns out that the treatment has to be based upon individual differences in people.
Thank you so much for joining me today, for sharing this information. And it sounds like exercise, and we all know it's good for us, but for folks with Parkinson's, the treadmill, this could really become an important part of treatment someday.
Oh, absolutely. So the way that I look at it is that the CDC guidelines, the exercise guidelines are good, as you correctly said, for everybody. If you have a progressive neurological disease, I want to focus on the word progressive neurological disease, then the added benefit of exercise is it may, I repeat, may slow the rate at which that disease progresses. And that can only be a good thing.
Well, thank you again for being on the show.
Thank you for inviting me. It's an honor.
You can follow us on Twitter at @NUFeinbergMed. Subscribe and ring the bell to hear about the latest groundbreaking research and discoveries. Thanks for listening.